Good evening, friends. Welcome back to Mastering Math with Saubhik Basu. Today we will discuss about concepts of limit, which is in the syllabus of class 11 for each of WBCHSE, CBSE and ISC. Now, for concepts of limit, we first know about what is neighborhood of any number. We all know about the real number line, which looks like this. 0 is always in the middle of this line. The right side of 0 will be plus, left side of 0 will be minus. We can see there is always a gap between each number. Between each number there is a gap. We can consider a number, suppose A, in this neighborhood, suppose A. So this will be A plus 1, this will be A minus 1. Okay. Now we consider a number very small, infinitely small number, delta. Suppose delta is 10 to the power minus 47, very small. If we subtract this infinitely small number from A and add this number with A, we can select this is A plus delta and this is A minus delta. Okay. So every number lying between A minus delta and A plus delta will be called the neighborhood of A. Okay. We can write this like this: x belongs to real number such that A minus delta is less than x less than A plus delta. Every x belonging to real number, if the value of x is greater than A minus delta and less than A plus delta, then it will be called the neighborhood of A. Now, the numbers in A minus delta and A, open interval A minus delta and A, will be called the left neighborhood, the left side, A minus delta and A, the left side, left neighborhood of A. Now the numbers in A comma A plus delta, that means open interval A comma A plus delta, A comma A plus delta, this will be called the right interval, that means the right side of A, right neighborhood of A, and A minus delta comma A will be called the left neighborhood of A. Now let x is a number which is not equal to A but very close to A. X can be slightly less than A, can be slightly more than A. We will write this as x A. We can say it as x tends to A or x approaches to A. Now, how can we determine if x is slightly less than A or slightly more than A? That means if x is approaching to A from its left side or its right side, for this we will denote it as x tends to A minus if x is approaching to A from its left side, and x tends to or x approaches to A plus, that means x is approaching to A from its right side, from the greater side. Now we consider a function. Okay, we consider a function. Now we are approaching to the, we are approaching to the concepts of limit. Okay, let a function fx such that x square plus 3. Okay, x square plus 3. X square plus 3. Now, what will be the value of f2? The value of f2 will be 2 square plus 3. That means 7. Okay. Now, if the value is not is equal to 2, it can be slightly less than 2. Okay. It might be less than 2. It might be slightly more than 2. So what will be the value of x? The value of fx if the value of x is slightly less than 2 or slightly more than 2. Let's discuss about this. To give the answer of fx, what will be the value of fx if x is slightly less than x? That means x tends to or approaches to slightly less than 2, that means 2 minus. For this, we will write it as limit x tends to 2 minus or limit x approaches to 2 minus. That is the limit. Limit x tends to 2 minus fx, that is limit x tends to 2 minus x square plus 3. For this, to give the answer of this question, we will consider x as 2 minus h. Why 2 minus h? As x is approaching to the left neighborhood, left hand side of 2, the lesser part. That's why 2 minus h. Now what is h? Let's say h is another infinitely small number. Suppose 10 to the power minus 57 or maybe 10 to the power minus 37 or 35. It may be anything very small. Okay, x is equal to 2 minus h. Now we put the value of x as 2 minus h. So that will become limit x tends to 2 minus x square plus 3 will be limit h tends to 0, 2 minus h square plus 3. Now why h tends to 0? Let's discuss about why h tends to 0 when x is tends to 2 minus. Okay. We have considered x as 2 minus h, right? That means h is equal to 2 minus x, right? When x is approaching to 2 from its left side, it's nearer to 2. That means when x is tending to 2, is approaching to 2, x is tending to 2, very near to 2, then what will be the value of h? When x is tending to 2 minus, let x is very near to 2, that means 1.99 something. Okay, then 2 minus 1.99 will be what? 0.01, which is very near to 0. Then when x tending to 2, h will tend to 0. That's why when x tends to 2 minus, h will approaches to 0. Okay. Okay. So let's solve this. What will be the value of this? Limit h tends to 0. Okay, 4 minus 4h plus h square plus 3. Okay. What will be this? This will be limit h tends to 0, 7 minus 4h plus h square, right? This will be limit h tending to 0, 7 minus h, 4 minus h, right? Now, if we put the value of h as 0, it is very close to 0. Okay, we can write this as 7 minus 0. Why 7 minus 0? We put the value of h as 0. Okay, we are putting this as the h is very near to 0. We can consider it like h is equal to 0. 4 minus h, 4 minus consider 0, it will be positive, and so that minus into plus will be negative. 7 minus 0, which is 7. Now let x is tending to the positive side of 2, x tends to 2 plus. For this we will consider x as 2 plus h, slightly greater than 2. H, we have considered h as this minus 35, 10 to the minus 35. Now what will be the value of fx when x is approaching to 2 plus? We have considered x as 2 plus h. We have seen that when x tending to 2 plus, then h will tend to 0, right? Why? X minus 2 is equal to h. When x is approaching to 2, h will tend to 0, right? That's why it will be limit h tends to 0, suppose plus f of 2 plus h. What is this? Limit h tends to 0 plus 2 plus h square plus 3. What is this? Limit h tends to 0 plus 4 plus 4h plus h square plus 3, which is limit h tends to 0 plus 7 plus h plus 4, right? If we put the value of h as 0, why? As h is very close to 0, then we can write it as 7 plus 0, which is 7. So what we have found? We have found limit x tends to 2 minus fx is equal to limit x tends to 2 plus fx is equal to 7. When we find that the negative approach of x, that means x approaching to 2 from its left side, okay, x approaches to 2 from its left side, and when x approaches to 2 as from its right side, if both the limits from left side and from right side equals, then we can write limit x tends to 2 fx is equal to 7. Now there is a question arise, when what will be this limit will called? And what will be this called? Now, limit x tends to 2 minus, this limit will be considered as left hand limit. We can write it as LHL. Okay. And limit x tending to 2 plus, this will be called the limit of right hand side. That means the right hand limit, that is RHL. Okay. When the left hand limit is equal to right hand limit, we can say the limit is verified. The limit exists. Okay. Now do it with some example. Let's consider a function as fx is equal to x square minus 1 divided by x minus 1. We can easily say that this function is not valid at x is equal to 1. When x is equal to 1, fx becomes 0 by 0, which is invalid. Now elaborate the function. Okay. Elaborate the function. Fx is equal to x plus 1 x minus 1 divided by x minus 1 is equal to x plus 1. Only when x is not equal to 1, right? Now let us consider x is very close to 1. This will be 1.000001. This is approaching to 1 from which side? From right side, the positive side. When x is equal to this, fx will be 2.000001, right? We decrease the value of a1. We are decreasing the value of 1 that much, then fx will be decreased to this much, right? That means how much x is approaching to 1, fx will be approaching to 2. X tending to 1 plus, fx is tending to 2 plus. Now let x is approaching to 1 from its left side, the negative side, the lower side. Then fx will be what? When x is 0.9999, fx is 1.9999. When if x is very close to 1, fx is very close to 2. When x is more close to 1, fx will be more close to 2. That means when x is tending to 1 from its negative side, fx is tending to 2 from its negative side. Okay. Now let us discuss about some more functions. Let's discuss about the previous function first. What was it? It was x square minus 1 divided by x minus 1, which was x plus 1 when x is not equal to 1. Okay. Now, what will be the limit of fx? What will fx when limit x tending to 1 minus? We have seen this with example. Now we see with the procedure. This will be this. We can write x as 1 minus h as the previous one. 1 minus h is very small number, infinitely small number, and that is why when 1 x is approaching from the left hand side of 1, that's why h is subtracting from 1. When x is approaching to 1, h is approaching to 0, right? Limit h tends to 0 minus 1 minus h plus 1. That means if we put the value of h as 0, that means 2. This is the left hand limit. What will be the right hand limit? Limit x tends to 1 positive, x plus 1 will be limit h tends to 0. Why it tends to 0? X is equal to 1 plus h, that means h is equal to x minus 1. X is approaching to 1, h is approaching to 0. That's why h is approaching, will approach to 2, and this will be 1 plus h plus 1. That means 2 plus h. When we put the value of h as 0, this will be 2. We can see the left hand limit is 2, the right hand limit is 2. Both are same. That means what? That means limit x tends to 1 fx is equal to limit x tends to 1 x square minus 1 by x minus 1 is equal to 2. It is same from the both direction, the positive hand direction and negative hand direction, the right hand direction, the left hand direction. That's why we are not writing any sign here. Limit x tends to 1, fx is equal to limit x tends to 1, x square minus 1 by x minus 1 is equal to 2. Okay. Mind it, x is not equal to 1. X is very close to 1. When x will be 1, this function will be invalid. Mind it. Now let us consider another function, the greatest integer function. What is this? We know what is greatest integer function. Greatest integer function is, for this will be 2. For this will be 1. Why? When we have to find the greatest integer function, the value will equal to the nearest lower integer of the value, right? Let's consider a function limit x tends to 2, the greatest integer function of x. At first we have to find out what will be its left hand limit. That means limit x tending to 2 minus, what we have to do? We have to consider a value h such as x is equal to 2 minus h, where h is very close to h, a positive number which is very close to 0. Okay, that's why 2 minus h is very close to 2, x is very close to 2, x is tending to 2. Now limit h tends to 0 minus, I am not doing this once again, 2 minus h, where 2 minus h is very close to 2 but slightly lower from 2. Suppose the value of 2 minus h is 1.999999. Okay, suppose 2 minus h is equal to 1.99999. Okay, then this will be 1.99999 and this will be 1. Why? The nearmost lowest integer. Okay, this is the left hand limit. Now what will be the right hand limit? This will be limit x tending to 2 plus, which is limit h tending to 0 plus 2 plus h, like this, where 2 plus h is very close to 2 but slightly greater than 2. Let 2 plus h is equal to 2.00001. Okay, then this will be greatest integer function 2.00001, which will be 2. Why? The nearmost lower integer. Our left hand limit is 1, right hand limit is 2. Do they match? No, they are not matching. The left hand limit is not equal to right hand limit in this case. That's why this limit does not exist. Okay. Let us consider another function as fx is equal to x square minus 1 divided by x square minus 3x plus 2 when x is not equal to 1, and 2 when x is equal to 1. Okay. Now for limit x tending to 1 minus fx, the left hand limit, obviously, it will be limit x tending to 1 minus x square minus 1 divided by x square minus 3x plus 2. Now let x is equal to 1 minus h. X is very close to 1, that's why 1 minus h is very close to 1, that is h is very close to 0. That why h tends to 0 minus 1 minus h square minus 1 divided by 1 minus h square minus 3 into 1 minus h plus 2. That's why limit h tends to 0 minus 1 minus 2h plus h minus 1 divided by 1 minus 2h plus h square minus 3 plus 3h plus 2 is equal to limit h tends to 0 minus, plus 1 minus 1 cancels, h into h minus 2, 3 cancels, plus 2h plus h plus 1. We can cancel out the h. Why? As h is not exactly 0, very close to 0, that is limit h tending to 0 minus h minus 2 by h plus 1. We can write it as minus 2 by 1 is equal to minus 2. Why? We are putting the value of h as 0. Okay. Now let me erase this part. Okay. Let me erase this part for the right hand limit. For the right hand limit, what is this? This will be x tending to 1 plus x square minus 1 by x square minus 3x plus 2. We consider x as 1 plus h, which is very close to 1. That's why limit h tending to 0 plus 1 plus h square minus 1 by 1 plus h square minus 3 into 1 plus h plus 2. That says limit h tending to 0 plus 1 plus 2h plus h square minus 1 by 1 plus 2h plus h square minus 3 plus 3h plus 2. Okay, that is limit h tending to 0 plus 1 minus 1 cancels, h into h plus 2 divided by 3 cancels, h into h plus, this will be minus h minus 1. We can cut the h. Why? This is h is not exactly 0. We can write it as limit h tending to 0 plus h plus 2 divided by h minus 1. If we write the value of h as 0, it will be 2 by minus 1 is equal to minus 2. What was our left hand limit? If you remember, it was the left hand limit was minus 2. The right hand limit is also minus 2. That means limit x tending to x positive fx is equal to limit x tending to 1 positive fx is equal to x tending to 1 negative fx is equal to minus 2. That's why the value of fx when x is tending to 1, when x is tending to 1 from both sides, it is minus 2. And what is the value of fx when x is exactly 1? When x is exactly 1, the value of fx is equal to 2. If you remember the function. Okay. So that's all for today. Next day we will discuss elaborately about limit, about the concepts of limit. Thank you.